Hello everyone and welcome back. In this video we're going to continue our discussion on normal random variable, and specifically we want to talk about non-standard normal random variables. In the previous video we learned how to read probabilities associated with the standard normal random variable, which is z, from the z table. But what if we have a non-standard normal random variable, such as x, and those mean and variances are not equal to 0 and 1, and that's called a non-standard normal random variable. We need to transform x to z so that we can read the probabilities from the z table. So that transformation needs to happen. How do we do that transformation? If x is a normal random variable having a mean of mu and a standard deviation of sigma, we can do that transformation using this little formula. Z is equal to x minus mu over sigma. And it might be a little vague at this point, but this is the transformation. And let's look at one example so we can make this more clear. This one says, Duracell manufactures AA batteries for use in a wide variety of commercial products. The production line of Duracell is designed and operated in such a way that X, the voltage of any given battery produced on the line, is a normal random variable, having a mean of 1.5 volts and a standard deviation of 0.01 volt. So it looks like here we're dealing with a normal random variable x that is having mean of 1.5 and standard deviation of 0.01. So as you can see, it's not a standard normal. So let's see what we need to do. Part A, sketch the probability density function of x. Well, we know the information that we need to sketch this probability density function. So let's do that here. Part A, and it's a normal random variable with a mean of 1.5, and it's always good to mark mu plus 3 sigma limit and mu minus 3 sigma limit on a normal bell curve so that you know where are the limits. So that would be 1.53, and here would be 1.47. Well, that means the batteries that are being produced at this facility, almost 100% of them are going to have a voltage between 1.47 volt to 1.53 volts. So let's go back and do part B. What proportion of batteries has a voltage of 1.5 volt or less? Well, looking at this graph, this question is asking us for less than 1.5. For that, we don't need to transform x to z and use the table. We already know that it's half of the batteries. So what we can say is simply, half, or, 0.5. Part C, what proportion of batteries has a voltage of 1.515 volt or less? Well, now this is not that easy, right? 1.515 is here, and we're looking for this probability, less than that. So what proportion of batteries have a voltage of less than 1.515? So how do we calculate that probability? Here we need to do that transformation. So part C, we're looking for probability of x less than 1.515. And this is how we do the transformation. This is equal to probability of z less than, if you remember, the transformation was x minus mu over sigma. So I'm going to write that down here. And here in the next step, I will fill them out with their values. X is 1.515, what has been asked here, minus mu, and that is the average, 1.5 over sigma, which is the standard deviation, and that was 0.01. Now, let's calculate that. That is probability of z less than, if you do the math here, that is 1.5. Now, we transformed this non-standard random variable to standard. Now we can use the z-table to read this probability. We got to find 1.5, and that is here, and the second digit after decimal point is 0. So this is probability of z less than 1.5, 0.933. So that is equal to 0.933. About 93% of the batteries have a voltage less than 1.515. So now that you learned how to do this transformation, I want you to pause the video here and try part D and E and come back to the video. Now let's do part D. What is the probability that the voltage of the produced battery exceeds 1.49? So we're doing probability of x greater than 1.49. So part D, probability of x greater than 1.49. The first step that I would like to take in these situations is that change the probability to less than, because eventually we got to do that because the table is cumulative distribution, and we have to make this change at some point. So let's just do it in the first step, and I'm going to change this to 1 minus probability of x less than 1.49. Now I'm doing the transformation. 1 minus probability of z less than 1.49 minus 1.5, right? This is the mu, this is the x, over sigma, which is 0.01. Now if you do the math here, that is 1 minus probability of z less than -1. Now I have to read this part from the z-table. Well, to find -1, I have to go to the negative side of the table, and here we are, -1, and the second digit after decimal is 0, so the probability that I'm looking for is right here, 0.1586. So that is equal to 1 minus 0.1586, which is 0.841. Again, it's always helpful to project that on the graph. So 1.49 is kind of like here, and we calculated the area under the curve after 1.49, right? And that is 84%. That makes sense. Now let's take a look at part E. What is the probability that the voltage of the produced battery is at least 1.48 but no more than 1.52? So here that means finding probability of x between 1.52 and 1.48, right? And we learned how to deal with these probabilities in the previous video. This probability is equal to probability of x less than 1.52 minus probability of x less than 1.48. And now we need to transform each one of these to z and then subtract the probabilities from each other. And if you do the math here, it's probability of z less than 2 minus probability of z less than -2. Now we need to read these two probabilities from the z-table. To find the probability of z less than 2, this is 2.0, and this is the second digit, so that probability is 0.977250. And for probability of z less than -2, we've got to go to the negative side of this table, and here is -2.0. The second digit is at the last column, So here, this is the probability, 0.02275. So this is equal to 0.977 minus 0.022 or 23 if you round it. So approximately we're looking at 0.954. About 95% chance that the voltage is between 1.52 and 1.48. Find the battery voltage X such that 2.5% of the batteries produced have a voltage greater than that. So at what voltage, about 2.5% of the batteries have larger voltage than that. So let's put that on a graph here, on a normal distribution graph. If this is the distribution of voltage, there is a voltage here, we call it X, that only 2.5% of the batteries have larger voltage, right? So what is that X? What we can say here is, just write that down mathematically. Probability of X, random variable X, voltage, being greater than that little x, this x here, is 0.025. Well, the first thing to do is, as I said, change the sign of this probability to less than, so we can be working with the table. So that means probability of x less than x is 1 minus 0.025, and that is 0.975. And that means this area, right? That is 0.975. So if that's the case, we can start the transformation here. Probability of z less than this little x that we don't know, minus 1.5 over 0.01 is equal to 0.975. Well, if that's the case, we can find the z value associated with 0.975 and make that equal to this part. Essentially, what we mean is x minus 1.5 over 0.01 is the z value associated with this on the table. And mathematically speaking, that z value is norm inverse of 0.975. So what we got to do is we got to go to the table and look for 0.975 within the table and see what z value is associated with that. And make it equal to this and solve for x. So let's go ahead and do that. So if you look into the table, you will see that right here we have that probability, 0.975. And the z value associated with that is 1.96, right? So let's go back. We can say that this is equal to 1.96. Therefore, you can solve for x. And if you solve for x, x is 1.5196. So looks like this x value here is 1.5196 volt. Part G is very similar. It says find the battery voltage X such that 1% of the batteries produced have a voltage less than X. So here we're looking at less than X, so we're on the other side of the normal distribution. So it's always helpful to put it on a normal bell curve, and that means there's an X here that only 1% of the batteries have a smaller voltage. What is that X? Well, we can follow the same process here. I'm going to let you guys work on that, pause the video, and come back. So probability of X, random variable X, less than this little x here, is 0.01. Well, we start by transforming this to z. X minus 1.5 over 0.01 is equal to 1%. Now, we need to go to the table and read the z value associated with 0.01. Essentially, x minus 1.5 over 0.01 is equal to norm inverse of 0.01. And that is that z value. So let's go to the table and find the z value associated with 0.01. So if you look into the table at negative 2.33, you'll see the closest value to 0.01. And that is here. So the z value associated with 0.01 is about negative 2.33. You can also go with negative 2.32 because it's between these two values. So I'm going to go with negative 2.33. So this is negative 2.33. And if I solve this equation for x, I'm going to get x equal to 1.477. So that is the voltage that we have here. And only 1% of the batteries have smaller voltage. So I hope this example helped you to make the transformation from a non-standard normal random variable to a standard normal random variable and use the z-table to calculate probabilities.